The Great Sphinx of Giza has a secret. It's in the stone. It's this monument, a lion's body, a king's head. But it's more than a symbol. It's a geological puzzle. It challenges what we think about its age. The rock it's carved from could rewrite chapters of human history. Its weathered surface hints at forgotten rainstorms. From a lost age, and that means something for the story of civilization. To discover our past might be far deeper than we imagined. For almost 200 years, that's been the standard story in Egyptology. The Great Sphinx was built for the pharaoh Khafre. That would be around 2500 BCE. It's a guardian in front of his pyramid, this huge stone portrait, meant to show power that lasts forever. And that age, 4500 years old, it comes from the archaeology at Giza. The Sphinx is sitting in a quarry, and that quarry supplied stone for Khafre's temple. The alignment matches his pyramid complex. There's also the Dream Stela. That's a granite slab put between its paws much later by Thutmose IV. It mentions the god Harmakhis, which later gets linked to the Sphinx, so the logic is clean. It fits right into the 4th dynasty's building project. But if you look closer, the dating isn't from a direct inscription. It's built on inference. There's no hieroglyphic text on the Sphinx naming its builder. No record from that time directly credits Khafre. The attribution is a deduction. It's the best fit based on where it sits and a stylistic resemblance to statues of that pharaoh. Then there's the head. It's so iconic, but it's noticeably small compared to the lion's body. That's led to this idea. Could the head we see be a recarving? A pharaonic remake of a much older rock formation, maybe even a natural one that already looked like some guarding creature. So this established timeline is a masterpiece of interpretation. But it's like the limestone it's made from. It's not impervious to scrutiny, and it left a big question. If we can't ask the Sphinx who built it, maybe we can ask the stone how old it is. That shift from archaeological context to physical evidence is where things really start, and it began not with an Egyptologist but with a geologist. Robert Schoch. Geology had its own evidence. It was right there in the rock. In the early 90s, Robert Schoch, he was a professor at Boston University. He looked at the Sphinx as a geologist. He wasn't interested in pottery or inscriptions. He was reading the limestone, and what it said was surprising. He looked at those deep vertical channels in the walls around the Sphinx. They weren't sharp from sand. They were smooth, rounded, like grooves in a riverbank. That pattern means something specific to a geologist. It means water. A lot of water, rain, over a very long time, so his conclusion was simple. The main weathering on the Sphinx, it wasn't from wind, it was from rainfall. And that changed the whole story. For the Sphinx to be carved and then weathered like that by rain, it had to be standing there when Egypt was much wetter. The last time that happened with that kind of heavy rain was at the end of the last ice age. That tapered off around 5000 BC, so that's 2,500 years before Khafre. Schoch's analysis said the core erosion could be that old, pushing the origins way back into a pre-dynastic past. That idea sent a tremor through Egyptology. It wasn't just about art history anymore or which pharaoh came when. It was a challenge written in stone. It made you see the desert differently. If Schoch was right, then who was carving these monuments? At the dawn of civilization, you see that weathering on the Sphinx enclosure walls. It's not a clean cut. It looks like a landscape, rolling, undulating. With these deep vertical channels going down and undercuts, softer stone eaten back, leaving harder layers sticking out like shelves. Now this is the Sahara. It's been a hyper-arid desert for thousands of years. The main erosive force here is wind and sand. It acts like a sandblaster. That kind of erosion creates sharp, horizontal features. It smooths surfaces. It doesn't carve deep, rounded grooves that look like they were made by water trickling down. And that's the thing. What geologists see on those walls, especially the older western end, is a textbook signature of precipitation. Of rainfall. Water running over limestone doesn't just wash it, it dissolves it. The water's slightly acidic. It reacts with the calcium carbonate. It finds the weaker layers, dissolves them faster. That's what creates the channels, the undercuts. The water cascades down, follows gravity, carves those vertical fissures. The depth of these features is critical. This isn't from a light shower. This is weathering that needs a lot of water over a very, very long time. It means the Sphinx sat exposed, its enclosure open to the sky. During a period when the climate here was different, when it was wet, lush even, so the enclosure becomes an archive, a climatic archive. Each groove is a line in a history book. A record of storms from a forgotten time. If the standard timeline is right, if the Sphinx was built around 2500 BC, the heavy rains had stopped millennia before. The Sahara was already becoming a desert, so how could rainfall of that intensity carve these features? The stone seems to be telling a different story. A much older one. The evidence isn't just about the Sphinx. To see what the stone is saying, you have to look at what's nearby. A short walk away on that same limestone plateau are the rock-cut tombs. Old Kingdom nobles, they're dated to the Pyramid era, that 2500 BC timeframe, the same period given to the Sphinx. They're ancient, weathered by thousands of years in the desert. And that's what makes them so useful. When you put the erosion on those tombs next to the erosion in the Sphinx enclosure, you're seeing two completely different stories. The tombs show the classic dry desert signature, surfaces smoothed, scoured by wind-blown sand, like a natural sandblaster over centuries. The edges are sharper. The wear is more uniform, horizontal, exactly what you'd expect for something sitting in an arid environment for 4,500 years. Then you look back at the Sphinx enclosure. Those deep, sinuous channels, the rounded hollows, the pronounced undercuts, the two patterns don't match. They're fundamentally different. Geology works with this kind of comparison. It's a controlled experiment set up by history. Both are made from the same bedrock. Both have been sitting on the same plateau, exposed to the same sun, the same wind for the same amount of time, if the traditional timeline is right. So why do they look so profoundly dissimilar? If the Sphinx was a contemporary of those tombs, its erosion should look like theirs, but it doesn't. That discrepancy is a second pillar of the argument. A powerful one. Those arguing for a revised age point to this contrast as undeniable. They say the Sphinx shows a type of weathering that requires a different climate altogether. Those deep, water-carved grooves suggest it was already standing, already exposed during a much wetter period in Egypt's past. It endured rainstorms that the Old Kingdom tombs, built millennia later, never knew. By the time those tombs were carved, the climate had shifted. The heavy rains were a memory, locked in the stone of the older monument. This comparison does more than suggest an older date. It frames the Sphinx as an anomaly, an outlier on its own plateau, a relic from a different world, sitting there beside the more recent architecture of the pharaohs. The story goes deeper under the ground itself. The third clue isn't something you can see. It's hidden inside the stone. In the 1990s, a geophysicist named Thomas Dobecki brought a different tool to the site. A method called shallow seismic refraction. It's like a medical scan for the Earth. You send sound waves down, they bounce off layers and come back. By timing how fast they return, you can map what's underneath. The density, the structure, the hidden fractures, it's a way of reading the stone's internal diary. And what Dobecki's data suggested was startling. The weathering, the alteration of the rock, wasn't just on the surface of the Sphinx enclosure. It went deep. The pattern of density changes and fractures around the base pointed to something profound. There was evidence of deep subsurface chemical weathering. That's a process where water doesn't just run over the rock. It soaks in, it infiltrates, saturates, slowly dissolves minerals from the inside out, a process called leaching. Now, in the dry desert climate of the last 4,500 years, that kind of deep, pervasive saturation is hard to explain. Occasional groundwater, or the slow upward creep of moisture from the Nile capillary action, that usually creates a different pattern. A more limited one, it doesn't produce the widespread, deep-seated leaching the seismic data seem to show. That specific signature is a hallmark of prolonged, direct water infiltration. From above, from rainfall, so this hidden weathering profile paints a picture. It suggests the limestone around the Sphinx wasn't just occasionally damp. It was repeatedly soaked, saturated from the top down over a very long span of time, as if the stone absorbed centuries of wet seasons, recording each one in its internal fractures. For that to happen, the monument had to be there, exposed to the open sky, during a period when heavy rain was a regular part of the climate. That, again, points to a time long before the pyramids. This subsurface evidence acts like a corroborating witness. The surface erosion tells one story of water. The hidden, internal damage tells the same story from a different angle. Together, they build a case that the stone of the Sphinx holds memories of a much greener, much wetter Egypt, a world that had vanished long before the first pharaohs unified the land. The story of ancient rain has a strong counter-argument. What if the climate was different? Could Egypt have been wet enough around 2500 BC during the Old Kingdom to carve those grooves? That's the central question. It challenges the whole water erosion idea. The Sahara's drying wasn't a simple switch. The African Humid Period, that lush time, faded between 6000 and 3000 BC. But it was a slow retreat, not an abrupt stop. By the pyramid builders' era, the region was arid, but maybe not the bone-dry desert we see now. Some climate studies suggest pockets of heavier rain could have persisted. Sporadic, intense monsoon storms. These wouldn't have been gentle drizzles, they'd have been torrents, moving vast water in a short time. Critics of a revised Sphinx age say even a few centuries of those occasional downpours could have been enough. If the Sphinx was carved in 2500 BCE and then exposed to a few hundred more years of diminishing rains, could that explain the erosion? They point to other sites, evidence of more active wadis from that later period, traces in soil and pollen, hints of a slightly wetter, more variable climate lasting longer than the simple model of an instant desert allows. So the debate becomes a calibration. It's not just about whether it rained, it's about how much, how often, and for how long. You have to match the specific, deep weathering on the stone with a plausible rainfall history. Could sporadic storms over a few hundred years create erosion that looks, to a geologist, like it took millennia? Or does the depth and rounding of those channels demand a much longer, more consistent soaking? This is where the puzzle gets technical. It moves from observation to calculation. Scientists model erosion rates. They try to quantify the relationship between rainfall intensity and limestone dissolution. It's a complex equation, many variables. The answer isn't clear-cut. One side sees a climatic window that closed too early for the traditional date. The other sees a window that was still cracked open. Just enough, the stone holds the answer, but we're still learning how to ask the right questions. The Sphinx has this other complication, a physical one. It's right there on the surface. This isn't a pure monument carved once and then left alone. It's more like a document, written, erased, and rewritten in stone. Over and over across thousands of years, from the pharaoh's own time through the Romans, and then with big modern campaigns, layer after layer of restoration masonry. Blocks of a different limestone mortared onto the original core. They act as a shield holding the ancient shape together, but for a geologist they're a blindfold. The challenge gets huge. You have to look through these historical patches. You have to tell the difference between the weathering on the original bedrock, the stone that holds the climate signal, and the completely different wear on the restoration layers. Layers added centuries later or even millennia later. Each repair block has its own age, its own exposure history. The weathering on a block from Thutmose IV's time isn't the same as the weathering on the core body. And a modern cement patch from the 1980s tells a story about 20th century pollution, not ancient rain. Critics of the revised dating theory, they focus on this. They argue the severe damage we see, the damage that made all these repairs necessary, might not come from prehistoric rainfall at all. The original limestone is vulnerable to other forces. Salt crystallization is a major one. Groundwater full of salts can seep up through the rock. The water evaporates in the desert heat. The salts crystallize inside the stone's pores. That crystallization creates tremendous pressure, like ice expanding in a crack. It can spoil off entire layers of rock from the inside. This process doesn't need heavy rain. It just needs moisture and heat, rising groundwater from the nearby Nile, or even capillary action pulling moisture up from the plateau's water table. That could drive this kind of damage for thousands of years. Then there's the modern factor, industrial pollution, especially in the last century. It put acids into the atmosphere. Acid rain or even acidic dew can dissolve limestone aggressively. It's a rapid, recent form of erosion, and it can mimic, in some ways, the effects of much older water wear. So the question becomes, how much of that deep, rounded channeling is from ancient precipitation, and how much is from these other processes, slower processes or more recent ones? Disentangling this is the great puzzle. It requires looking not just at the shape of the erosion, but at its chemistry, the mineral deposits left behind. The specific patterns of fracturing. The restoration work saves the monument, but it also obscures the very evidence we need to understand it. To find the truth, you have to learn to read between the blocks. The stone has its own story, told through the marks it carries, but reading it means being careful. To even consider the idea of ancient rain, you have got to rule out the other sculptors. The ones that work in silence year after year, century after century. There's salt crystallization. In a place like this, salts are everywhere in the groundwater, in the air itself. Moisture gets into the limestone, then the sun bakes it dry. The salts are left behind. They crystallize inside the rock in the tiny pores, and crystals grow. They expand with this immense pressure like little wedges pushing the stone apart from the inside. That process is called exfoliation. It makes the surface flake off in sheets. You see that layered, peeling look on a lot of desert rock, but does it create those deep, rounded channels, the ones that run vertically for meters down a wall? Geologists who look at this say usually no. The salt weathering signature is more about surface spalling, a shedding of layers. It doesn't explain the profound incision. The channeling you see in the Sphinx enclosure. Then there's the wind. The desert wind doesn't just blow, it carries sand. It's a natural sandblaster, scouring everything, polishing surfaces. It's efficient, it smooths things, it creates sharp edges on the windward side, softer curves on the leeward side. It makes facets and angles, but again, the signature is different. Wind and sand abrasion tends to be more horizontal. It follows the dominant wind direction. It doesn't carve these sinuous, vertical gullies that go against the prevailing wind. The patterns on the Sphinx walls, especially those deep channels, they cut against the grain of what wind alone would do. A more compelling alternative might be groundwater. The Giza plateau sits above a water table. Moisture can rise up through the rock through capillary action, like water soaking up through a sponge. That could certainly weather the stone, especially at the base. But this process has a predictable limit. It creates a horizontal band of deterioration, a kind of tide mark of damage that lines up with the water table level. The weathering would be worst right there, in that zone of constant wetting and drying. What we see on the Sphinx, though, is vertical weathering. It extends high up the enclosure walls, far above any plausible ancient groundwater level. The damage isn't confined to a band, it cascades down from the top, so you're left with a process of elimination. Each of these desert forces, salt, wind, rising groundwater, they leave a distinct geological fingerprint. And they've all worked on the Sphinx over its long life, but their signatures don't fully account for the primary pattern, the deep, rounded, vertical channels. The pronounced undercuts, the rolling, undulating walls that look less like a desert formation and more like a limestone landscape from a wet climate. That elimination is key. If the other explanations don't fit the evidence as well, the hypothesis of precipitation erosion gains strength. It becomes the explanation that best matches the peculiar fingerprint on the stone. It suggests the Sphinx endured a different kind of storm, not a chemical process from within or a scouring from without, but a relentless, sky-born weathering. From a time when the desert was a different place entirely. Look at the Sphinx, the face, then the pause. The difference is there. The body is all these deep hollows, these channels. It looks soft, almost melted, but the head, the king's face, it's sharper. The headdress lines, the planes of the cheeks, they're crisp. The body isn't like that. It's two different stones, really, from the same rock but telling two different stories of time. That's not just an artistic thing, it's a clue. The standard view has answers. They say the head is made from a harder limestone layer, a better block, or it was recarved later in pharaonic times, reshaped from something smaller. So its weathering started later, or it's just been restored more, patched and repaired over the years. All of that could be true. We know the head and neck have been shored up with masonry, especially recently, to keep it from falling. But geologically, that contrast points somewhere else. It ties to the water erosion idea. If the body's deep weathering is from rain, millennia of it, then why isn't the head the same? Why is it less ravaged? The answer might be simple. For a very long time, it wasn't there, or it wasn't exposed. Imagine the Sphinx wasn't finished all at once. The body is carved from the bedrock, but the head, what if the original head was different, a natural rock outcrop? Maybe it looked like a lion or some guardian. Early people saw it and revered it. Then later, a pharaoh's sculptors came. They took that old, already weathered rock and refined it. They carved the human face we know. They shaved away the rain-worn surface. That act of carving reset the weathering clock on the head. The body kept its ancient scars. There's another possibility. Sand, the Sphinx has been buried over and over. For centuries, the desert covered it. Only the head stuck out above the dunes. The body was entombed in dry sand, protected from more wind or rain. But if the water erosion happened first, in a much older, wet period, then the damage was already done to the body. The scars were locked in. Later, during those long burials, only the head was exposed. It weathered slowly under dry wind and sun. The body's ancient wounds were preserved underneath the sand. That could explain the split, a body marked by ancient storms. A head worn only by the gentler desert of the last few thousand years, which leads to a question. Is the face we see the original face, or is it a later mask placed on a much older body? The geology hints the monument might be a composite, a fusion of times, an ancient, weathered form given a new identity by a later civilization. The body holds memories of a forgotten climate. The head looks out with the face of a pharaoh. That disconnect isn't just curious. It suggests the Sphinx's story isn't one moment of creation. It's a long dialogue between people and a stone that was ancient before history began. The stone of the Sphinx has a much longer history than anything humans have built. To think about how old it is, you have to start with the rock itself. It's a specific limestone from the Mokattam Formation. That layer was laid down in the Middle Eocene about 50 million years ago. The world was different then. The continents weren't where they are now, and the place that's the Giza Plateau today was a warm, shallow sea. So this stone is an ancient seabed. You can see the proof in the rock, these small, circular shapes. They're nummulites, fossils of single-celled organisms, foraminifera. They look like little coins. The pyramid blocks have them, and the Sphinx is carved right into this fossil layer, what geologists call member 2. So the material is unimaginably old. After the sea left, geological forces lifted that whole seabed. It became a plateau, and for tens of millions of years that limestone sat there. It was weathered by natural processes, by climates that existed long before any humans. That's the background. The Sphinx sits where two timelines meet. There's deep time, the millions of years of the rock forming and being exposed. And then there's human time, the few thousand years since it was carved. So the geological question isn't when the stone formed. We know that. It's about finding, within that huge span, the much smaller moment when people started carving it. Geologists looking at the erosion are like forensic investigators. They're asking one thing: when did this specific rock face, the body of the Sphinx, first become exposed to the air? How long has it been a surface facing the wind, the temperature changes, and especially the rain? They're trying to measure the duration of subaerial weathering in the open air on this exact outcrop. The goal is to separate the ancient, slow weathering of the plateau from the more recent weathering that happened after the carving. It's a subtle task. The evidence is layered over eons, but if the patterns on the walls show a type of weathering that needs a wet climate, and if that wet climate ended thousands of years before the traditional date for the Sphinx, then the carving has to be older. It has to fit into that earlier window. The stone's memory of rain becomes a clock, and it might be saying that the human part of this story didn't begin with the pyramid builders. It began with a culture lost to an even deeper past. Before the geologist, there was the questioner, John Anthony West. He wasn't an Egyptologist, he was an independent researcher. And he was looking at the Sphinx and he saw something about the erosion. It didn't look like wind to him. It looked like water damage, like rain. And if that was true, then the whole history of the monument, the official history, was wrong. But he had a problem. He wasn't a scientist. He didn't have the tools. He didn't have the credentials. His idea was just a radical hypothesis. It was outside of everything. To be taken seriously, he needed someone from inside the scientific community. He needed a geologist, and that's how he found Robert Schoch. West's role was the catalyst. He asked the question. He connected an esoteric philosophical idea to a tangible, geological anomaly. And then he brought Schoch to Egypt to see it. He provided the spark. Schoch provided the method. That partnership changed everything. Then West became the popularizer. Through books, through a documentary, he brought this geological controversy to a huge audience. He framed it not as some dry academic debate, but as a mystery. A cover-up of humanity's true past. Now, it's important to see the full picture. A lot of West's broader conclusions were highly controversial. His theories about a lost, advanced civilization, his interpretations of symbolism, mainstream scholars rejected these ideas. They saw his methods as speculative, more intuition than evidence, but even his critics had to acknowledge the power of his core question: what caused the erosion? That question was valid, it was specific, and it was testable. By insisting on it, West forced a geological lens onto an archaeological puzzle. He showed how an unconventional idea, a heretical idea from outside the mainstream, can sometimes push scientific inquiry into new territory. For better or worse, he made the world look at the Sphinx not just as a statue, but as evidence, sedimentary evidence. He turned a monument into a mystery. And in doing that, he made sure the stone would have its day in court. The reaction from Egyptology was immediate and sharp. To many archaeologists, this wasn't just a different idea. It felt like an attack on a story they'd built carefully over a long time. Their argument was that geology is a blunt tool for dating something like this. A rock face weathers for thousands of years before anyone carves it. The erosion can tell you how long the stone has been exposed, but it can't tell you when someone decided to shape that stone into a lion. The real date, they said, comes from context, from the human story around it, and that context for them is everywhere. The Sphinx isn't alone, it's the center of a complex. Just to the east, there's the Sphinx temple, built from huge limestone blocks that match the size and the quarry marks of the stone taken from around the Sphinx itself. That temple connects by a causeway to the Valley Temple of Coffer. The whole layout, the Sphinx, its temple, the Valley Temple, Coffer's pyramid, they align with a precision that points to one project. One building campaign, to pull the Sphinx out of that, to put it thousands of years earlier, creates a vacuum, a profound one. Where is the civilization that built it? Where are their tools, their pottery, their settlements, any writing? The Pre-Dynastic Period, before 3000 BCE, shows villages, early chiefdoms. It's impressive, but there's no evidence of stone carving on this scale. For most scholars, that absence is everything. You can't have a civilization advanced enough to carve the Sphinx that leaves no other trace. The debate got heated. People arguing for the older date were called pseudo-scientists sometimes, sensationalists, chasing a story instead of evidence, and from the other side, mainstream Egyptology was called a closed guild. Protecting its dogma, unwilling to look at evidence from outside its own field. This polarization is a classic case. Archaeology and geology speak different languages. One speaks in artifacts, in stratigraphy, cultural context. The other speaks in mineral composition, erosion rates, climatic history. They ask different questions. They trust different evidence, and when they meet, they can talk right past each other. This tension isn't just about egos, it's about how we know the past. What do we prioritize? The physical context of human activity, the pottery, the foundation deposits, or the physical testimony of the stone itself? Read through natural science. The Sphinx sits right at that crossroads. Its age is an open question, not because the evidence is weak, but because the evidence is seen through two different frameworks. Two conflicting ways of knowing. To get why the mystery lasts, you have to see that clash. History isn't just discovered, it's argued over, piece by piece. From the ground up, the geological debate didn't stop with one man's analysis. Other scientists have looked at the stone since then. They've brought their own tools, their own eyes. And they've offered support and also sharp critique. This independent scrutiny is crucial. It moves an idea from a single theory into a wider conversation. One prominent voice in support was the geologist David Coxhill. He did his own examination. He concluded the erosion was pluvial, meaning caused by rainfall. His agreement added weight. He wasn't part of the initial team. He came to his own conclusion, looking at the same evidence. For him, the weathering patterns just didn't match what you'd expect from wind and sand alone over 4,500 years. The depth, the rounding, pointed to water as the primary sculptor. Yet other geologists have looked at the same walls and seen a more complex story. One major critique focuses on the limestone itself. The rock isn't uniform. It's made of different layers, members with varying hardness. Some are dense and resistant, others are softer, more crumbly. This variation, critics argue, is the real key. What we see might not be the signature of ancient rain, but of differential erosion. The softer layers wear away faster under any condition: wind, occasional moisture, salt. The harder layers protrude, Over millennia, this natural variation in the rock could create that rolling, undulating appearance, the shelves and hollows, without needing a radically different ancient climate. It's a process of multiple agents working on an already variable canvas. Another point involves the shape of the Sphinx enclosure. It's a pit, a deep, excavated hole in the plateau. Some geologists note that such a depression would act as a catchment basin. Even in an arid climate, when rare, heavy storms did occur, all the runoff from the surrounding plateau would funnel into this bowl. The water would cascade down the walls in concentrated torrents. This focused, localized flooding could cause significant erosion relatively quickly. The argument is you don't need centuries of consistent rain. You just need a few catastrophic flash floods over hundreds of years to carve those channels. The enclosure's own geometry amplified the power of whatever water did fall. So the independent assessments show there's no unanimous consensus, even among geologists. The stone is a complex text. Experts read it differently. Some see a clear climatic fingerprint pointing to great antiquity. Others see a landscape shaped by the rock's own inherent weaknesses, exaggerated by local conditions. This ongoing discourse isn't a weakness of the idea. It's a strength of the scientific process. It means the question is being taken seriously. It's being tested. And as new technologies emerge, higher resolution scanning, better geochemical analysis, our ability to read that stone diary improves. The conversation continues to evolve. Not with shouting, but with closer observation. Each critique refines the question. Each new observation adds a piece. The Sphinx, silent as ever, waits for us to learn how to listen. Right next to the Sphinx, there's another structure, the Sphinx Temple. It's a low platform made from these huge limestone blocks, enormous stones, hundreds of tons. And they're the key because those blocks have a specific origin. They were cut right from the Sphinx enclosure itself. As they carved the lion's body out of the bedrock, they were quarrying the stone for this temple next to it. So the stone is identical, the same layer, the same member of the Mokattam formation. That gives us a perfect comparison. The blocks in the temple and the walls of the enclosure are geological twins. They share the same history up to a very specific point, the moment they were separated, the day a block was cut free and moved into the temple wall. And here's where it gets interesting. If you look at the surfaces of these core blocks inside the temple, they're not smooth. They show weathering, erosion patterns. But the critical detail is this. The weathering is on the surfaces that were exposed when the block was still part of the living rock, the sides that faced the open air in the enclosure. When they quarried the block, turned it, and set it into the wall, that weathered surface was often placed facing inward or in a protected spot. It was a surface that had already aged. So that weathering happened before the temple was built. It's pre-construction weathering, a snapshot of what the Sphinx enclosure looked like the moment the blocks were taken out. That's a fixed timestamp. If we can read the type of weathering on those block faces, we know what forces were acting on the enclosure right before Kaffa's builders arrived. Now, if that weathering on the protected faces shows the same rounded, channeled, water-induced patterns we see on the deeper enclosure walls, the implication is deep. It means the process that carved those grooves was already well underway. The Sphinx enclosure wasn't a fresh quarry when the 4th dynasty Egyptians started. It was an ancient, weathered landscape. The stone bore the scars of a different climate. The builders of the Sphinx temple were recycling an already ancient site. They were taking blocks from a wall that nature had been sculpting for a very long time. That turns the traditional story around. It suggests the Sphinx we know might not be a 4th dynasty invention from scratch. Instead, the 4th dynasty pharaohs could have encountered a natural or a much earlier man-made rock formation that was already deeply eroded. They redefined it. They excavated it further, maybe recarved the head, and built their temple next to it using the stone they removed. In that scenario, Khafre's people aren't the original architects. They're the inheritors, the restorers of a monument from a lost age. The geological clock frozen on those temple blocks would have started ticking long before the first pyramid. The mystery doesn't stay in Giza. If the stone is right, if the Sphinx really saw the end of the Ice Age, then what else have we missed? For some, it's not just one monument. It's a piece of something bigger, a global puzzle. They look at other ancient sites, places that don't fit the timeline. In southeastern Turkey, there's Göbekli Tepe, a huge complex, massive stone pillars in circles carved with animals, and its age archaeology dates it to around 9,600 BCE. That's over 6,000 years before Stonehenge. And it was built by hunter-gatherers, people we thought couldn't do that. Then across the ocean, in the Gulf of Mexico, the Olmec left those colossal stone heads. Each one weighs many tons, distinct helmeted faces. Their origins, their knowledge still a deep enigma. The standard story says these cultures developed alone. But what if the threads connect? The speculative idea is these sites aren't separate miracles. They're fragments, surviving pieces of an older, shared cultural layer. A sophisticated understanding of astronomy, engineering, stonework, from the dawn of our current climate age. In that view, the Sphinx isn't an outlier. It's a surviving sentinel from that lost world. Its water scars, a testament to the great climate shift that may have scattered human societies. Now, this is highly speculative. Mainstream archaeology points out there's no direct evidence, no shared artifacts, no identical scripts linking these disparate sites. Each one sits in its own clear cultural sequence. The leap to a global, advanced precursor civilization is enormous. But the power of the idea isn't necessarily in its proof, it's in the question it forces. Redating the Sphinx isn't just moving an Egyptian statue back on a timeline. It has a ripple effect. It challenges the framework of how we think civilization began. Was it a slow, linear climb from simple to complex, happening independently in a few river valleys? Or could it be a story of cycles, rises, and catastrophic falls? Knowledge lost and rediscovered over vast stretches of time. The geological evidence at Giza, if it's validated, doesn't prove a globe-spanning empire. But it opens a door. It invites us to consider that the history we've written, the one that starts with Sumer and Egypt around 3000 BC, might not be the first volume. It might be the sequel. The monuments standing in silence around our world may be keeping a secret, not just about who built them, but about when, and more importantly, about what we, as a species, are truly capable of remembering. The stones keep their secrets, but we're learning to ask in different ways. The debate over the Sphinx's age, it's not just a clash of opinions anymore. It's becoming a conversation with data, using tools that see what we can't. Ground-penetrating radar. It sends pulses into the earth, maps the density, the fractures deep inside the limestone plateau. Shows the internal architecture, shows how far the weathering goes below the surface. Then there's 3D laser scanning, LiDAR. It captures the monument, the enclosure, with millimeter precision. Creates a perfect digital twin, a map of every groove, every undercut, every contour, and that's more than a record. It's a lab. With that exact model, scientists can run simulations. Program virtual rainstorms, different intensities, different durations, and watch over accelerated time how water would flow down those specific walls. Which channels it would deepen, what patterns it would leave. Then they compare those simulated erosion patterns to the real ones from the scan. It becomes a test. Does a few centuries of Old Kingdom rainfall produce the digital scars we see? Or does it need a much longer, wetter period, something like the end of the last ice age? That moves the question from a qualitative argument into quantitative modeling. Then there's the chemistry of the stone itself, advanced petrographic analysis. Looking at thin slices of limestone under powerful microscopes, reading the mineral story, but more telling is the weathering rind, that altered layer on the rock surface. The specific minerals that form there, the isotopic signatures locked inside, they can act like a climatic fingerprint. They might reveal whether the main weathering agent was acidic rainfall, or groundwater full of salts, or something else. Each process leaves a distinct chemical marker, so by sampling the rind from the deepest channels and comparing it to samples from Old Kingdom tombs or from known climatic events, researchers could one day pinpoint the conditions that created the Sphinx's texture. These tools don't give a single, simple answer. There's no scanner that beeps with a date. Instead, they build a more refined picture. They allow for testable models. Falsifiable models, the future of this mystery is in that convergence. It'll be less about which theory sounds more compelling, more about which model can account for all the new data, the subsurface maps, the chemical signatures, the simulation results. The stone has been patient for millennia, and now, with quiet electronic pulses and beams of laser light, we're starting to listen to its long story. With a new kind of clarity, the Sphinx isn't just a scientific question. It's about who we are, the age of this thing. It's not a neutral fact. It carries a lot of weight. For Egypt, the monument is a cornerstone of identity. It's a direct link to one of the foundational civilizations. So the idea that it could be from a forgotten culture, maybe even a non-Egyptian one from a much deeper past, that can feel like a diminishing. Like the most iconic symbol of pharaonic genius might be a hand-me-down, a relic from a people without a name that touches a nerve, a deep nerve of cultural pride, of ownership over history. Then there's the other side, the theory of a lost, advanced civilization. It has a powerful, almost mythic appeal. It offers an alternative to the standard story of linear, gradual progress. It suggests a grander origin, a fall from a golden age instead of a slow climb from simplicity. That narrative resonates. It speaks to a longing for forgotten wisdom, for a past that was more profound than our records show. It's a compelling story. It exists outside the official channels, so when a geologist talks about water erosion or an archaeologist points to a pottery shard, they're often seen as representing more than data. They become figures in a larger drama. One side gets accused of clinging to dogma, of protecting institutional authority. The other side gets dismissed as chasing fantasy, letting the desire for mystery override the evidence. The Sphinx becomes a battleground for competing visions of the human past. Is history a known, catalogued sequence, or is it a landscape full of sunken continents waiting to be discovered? That's why the feelings run so strong. It's rarely just about limestone dissolution rates. It's about narrative control, about which story gets to define our origins. The evidence becomes a proxy in an older conflict between tradition and revision, between established knowledge and the thrill of the unknown. Every core sample, every weather simulation, it gets examined not just for its scientific merit, but for which camp it seems to support. The stone of the Sphinx, silent and immovable, has become a mirror. It reflects back our own deepest questions about time, about legacy, about where we truly come from. There's a spot on the Sphinx, on the lower back, the haunches. The weathering there is strange. It doesn't follow the pattern you'd expect. Water running off the back should carve vertical channels, or the north wind should scour the stone in one direction. But the patterns here are chaotic. They swirl, they run sideways, in some places upward against the flow. It looks backward. That detail has become a case study. For researchers who argue for ancient rainfall, it's a key piece. Their interpretation goes like this. Imagine the Sphinx enclosure not as a dry pit, but as a temporary lake. During heavy, monsoon-like storms, rain would flood the hollow. Water wouldn't just run off, it would pool. It would stand for days, maybe weeks. In that scenario, the base of the Sphinx, the lower back, would be submerged. That standing water wouldn't be still. Wind would whip across the surface, creating waves, small waves lapping against the stone constantly. That wave action is a powerful erosive force. It doesn't come from one direction, it sloshes back and forth. It creates a swirling, multi-directional wear pattern, exactly the kind of chaotic erosion we see on the rump. It's the signature of a flooded pit. Other scientists look at the same stone and see a different process. They point to the limestone itself. It's not a uniform block. It's made of layers, like a stack of slightly different papers. Some layers are hard, others are soft and crumbly, and these layers aren't perfectly horizontal. They dip and tilt in subtle ways, so the rock weathers differently depending on which way you're facing. That property is called anisotropy. A complex micro-environment forms in that sheltered corner. Maybe occasional runoff gets trapped there. Maybe salts accumulate differently. The layered stone, with its varying hardness and orientation, wears in a complex pattern under normal desert conditions. It's not a climate clue, it's a geology clue. This one small feature shows why the debate is so intricate. You can't look at the Sphinx and make one sweeping statement. Every surface, every corner has been shaped by a combination of forces: the original climate, the rock's own personality, thousands of years of wind, sand, and maybe water. Later repairs, even modern pollution. To understand the whole story, you have to become a detective for every single scar. The backward erosion on the haunches is a perfect example. Is it the watermark of an ancient flood, or the natural fingerprint of a complicated stone? The answer lies not in choosing one grand theory, but in learning to read each mark on the monument's weathered skin. This is the main limit of the geological argument. Geology can tell you a story about the stone, but it can't tell you the story of the sculptor's hand. It gives you clues, but it answers a very specific question. How long has this rock face been exposed? That's the question. And from that exposure age, you try to get a construction date. But there's a gap in that. The erosion gives you a minimum age. It says the surface has been weathering for at least, say, 7,000 years. But that doesn't mean a person carved it 7,000 years ago. There's a chicken and egg problem here. Think about the Giza plateau 12,000 years ago, a natural limestone outcrop shaped by wind and rain. It already has deep channels, rounded hollows, a strange shape. Then, 4,000 years ago, people from the Old Kingdom arrive. They see this formation. It looks like a lion to them, or a guardian. They see its power, so they take tools and they refine it. They deepen the outline, carve the details, put a pharaoh's face on it. They turn an ancient, weathered landform into a monument. In that case, the geology is right, the stone surface is very old, but the human act of carving is much younger. The geology sets a boundary. It says the Sphinx as a rock surface can't be younger than the erosion on it, but it can't prove the Sphinx as a cultural monument is as old as that erosion. To close that gap, to find the moment of human intention, you need other evidence. You need archaeology, pottery, tools, debris, inscriptions. That puts people at that site at that specific ancient time. And for a date thousands of years before the Old Kingdom, that evidence isn't there. No settlement remains, no tools, no cultural layer from a stone carving society at Giza in that era. So the geological evidence is an anomaly, a question mark in the stone, but until other fields find evidence that matches it, the story isn't complete. The stone whispers about age, but the silence about people leaves you wondering. Are you hearing the start of a monument, or just the long weathering of a hill that became one later? That timeline is startling. It moves a date, but it also reimagines a world. If the deepest erosion on the Sphinx is from the terminal Pleistocene, Then that window closed around 5000 BCE. So the stone's most dramatic weathering happened during the African Humid Period, when the Sahara wasn't a desert, it was a savanna with lakes and rivers. Heavy, seasonal rains were still a powerful force. For the Sphinx to have those marks, its carved surface had to be open to the sky then, exposed, which means the act of carving had to happen even earlier. To give the rain time to do its work, that pushes the origins back into the 7th millennium BCE, or maybe further. On a human scale, that's a different world. This isn't the age of the pyramid builders. No centralized state, no written language, no bronze tools. This is the pre-pottery Neolithic in the Nile Valley. Communities were smaller, more mobile. Technology was stone, wood, and bone. The archaeological record from that time shows ingenuity, fishing, early cultivation, basketry, art. But it doesn't show monumental stone sculpture, not on the scale of the Sphinx. That's the tension. The geology suggests an ancient surface, but the archaeology doesn't show a society we recognize as capable. So we're left with possibilities, each one challenging. The first is that the geological reading is wrong, that the erosion came from later processes, and the traditional 4th dynasty date stands. The second is that our understanding of pre-dynastic capabilities is incomplete, that there was a culture in the Nile Valley now lost to us. With the social organization, the vision, the will to shape the living bedrock on that scale, they may not have been a civilization as we define it, no cities, no kings, but a society connected to place, for whom carving the guardian of the plateau was a generational act, a sacred act. A third possibility blends the two. Maybe the Sphinx began as a natural rock formation, etched by millennia of rain and wind into a form that suggested a crouching beast. A later people, the ancestors of the dynastic Egyptians, recognized its power. They refined it, they deepened the outline, defined the legs, and recarved the head into a royal likeness. In that scenario, the geology records the age of the natural form. The archaeology records the age of its transformation. This revised timeline isn't a settled fact. It's a hypothesis, but a powerful one. It demands we look harder at the silent millennia before the pharaohs. It asks whether the dawn of monumentality in Egypt wasn't a sudden invention, but the flowering of a seed planted in a much deeper and wetter past. The stone being older changes more than just a date. It means the story of where Egypt came from starts to shift. The 4th dynasty pharaohs were still brilliant. Their pyramids are still perfect. Their culture is still one of the foundations. But if the Sphinx is that old, it means something deeper. It means the old kingdom might not have been a sudden beginning. It could have been a renaissance, a golden age that was actually a rediscovery. Picture it, a people newly united under a god-king, moving their power across the Nile. They reach the Giza plateau, and there, coming out of the limestone, is this huge, weathered shape. It had been sitting for thousands of years, shaped by ancient rains into something like a crouching lion. To these early Egyptians, it wasn't just a rock, it was a sacred presence, a guardian from a time before time. They saw its power, so they didn't build it from nothing. They adopted it, they took tools and refined the natural outline. They deepened the legs, smoothed the body, and with reverence, they carved their king's face onto that ancient stone. They weren't inventing a monument, they were claiming one, consecrating a legacy they themselves felt was primordial. That changes the story completely. Instead of a culture appearing fully formed with all its engineering and ideas, you see a civilization consciously reaching back to a deep past. Their obsession with eternity, with cycles of death and rebirth, gets a new meaning. They might have believed they were restoring a world order that existed long before. Their texts sometimes talk about Zep Tepi, the first time, a mythical, perfect epoch at the start of creation. What if Zep Tepi wasn't just a metaphor? What if it was a cultural memory, a hazy recollection of the people who made that original, rain-scarred form. Then the Sphinx becomes a bridge, a physical bridge between two worlds, the world of its original, unknown makers, lost when the climate changed, and the world of dynastic Egypt, which saw in that stone a symbol of eternal kingship and divine protection. The pharaohs didn't just build for their own glory. They built to anchor themselves to a timeline that went back into the mists. Their greatest works might have been acts of restoration, acts of continuity. That adds a deep layer to their religion, their art, their idea of kingship. They weren't just founders, they were inheritors, and the silent, weathered guardian at Giza may have been their strongest link to that first time. A reminder that their golden age was, in truth, a reflection, a brilliant reflection of a much older light. The Sphinx's most personal secret is the face we never saw. That human face, the one we link to Pharaoh Khafre, might be a mask. The head is small, strikingly small for that massive lion's body, and it weathers differently, sharper, less rounded. That's fueled a question. Was it originally something else, a lion's head maybe, or a jackal? Some researchers point to the size, the odd neckline, as evidence it was recarved. If the body is older, as the erosion suggests, then the original head would have weathered in that same ancient climate. It would have become featureless or crumbled. And a later civilization could have taken that weathered stump and reshaped it into a new symbol. But without an inscription, without a hidden layer showing the prior form, it's just a theory. It's a ghost image, a silhouette behind the king's face that we may never see. Beneath the monument, the mystery goes down into the earth. Over the years, surveys have suggested anomalies, cavities, tunnels, chambers under the pores or beside the body. These hints come from seismic readings, from ground-penetrating radar, technologies that send echoes into the stone. The most famous is the Hall of Records, a legendary place said to hold lost knowledge. That's legend, but the physical anomalies are real data. They could be natural fissures in the limestone, ancient quarry pockets, or man-made spaces. For archaeologists, a sealed chamber, untouched, would be a treasure beyond gold. It could hold tools, offerings, inscriptions that finally date the site. But excavating there is a monumental risk. The potential for damage is immense, so these subterranean hints remain just hints, echoes in the dark, waiting for a technology precise enough to explore them without harm. The true breakthrough might not come from digging, but from looking more closely at the surface we already have. New geochemical methods can read the stone's history at a molecular level. Scientists can analyze the thin weathering rind on the limestone, the specific mix of minerals, the isotopic signatures locked inside these are chemical fingerprints. They can distinguish between damage from acidic rain, from salt-laden groundwater, or from wind-driven sand. By comparing samples from the Sphinx's deepest channels with samples from Old Kingdom tombs, from known climatic periods, researchers could one day pinpoint the primary agent of erosion. And by extension, the era it occurred. That's the promise of a more objective clock, a clock that ticks in isotopes and mineral bonds, not in assumptions. Because of these unknowns, the debate persists in a strange duality. On one side, there are serious, interdisciplinary efforts slowly growing. Geologists, climatologists, archaeologists are starting to share data, building models that respect both the stone and the human context. The call is for collaboration, to move past the old, entrenched positions. On the other side, the void of unanswered questions fuels endless speculation, tales of lost continents, advanced technologies, apocalyptic warnings. The Sphinx, in its silence, accommodates both. It's a solid archaeological puzzle and a blank screen for our deepest myths. This enduring enigma means the guardian of Giza is never just a static relic. It's an ongoing conversation. Each technological leap, from satellite imaging to portable spectrometers, gives us a new lens. We're learning to ask the stone more precise questions. And while it may never give up its secrets easily, Each fragment of data brings us closer to a story told not through legend or dogma, but through the immutable, patient language of geology itself. The final chapter is still being written, one grain of sand, one atomic signature at a time. The age of the Sphinx, that story isn't just in old journals or at the dig site. You see it everywhere now, on TV, in books, all over the internet, and in those places, the whole geological argument, it often turns into something else. A different kind of story, a more dramatic one. It becomes about hidden truth against official stories, about a few researchers fighting a whole academic system that doesn't want to listen. That framing works. It makes for good television. You get clear heroes, clear villains, a mystery that feels like it could change everything, and people connect with that. There's a real hunger for stories that challenge what the textbooks say. That thrill of thinking maybe we've got it all wrong. It's a powerful feeling. It hints that our past is deeper, more mysterious than we were told. But that media version, it has a downside. When you simplify everything down to a simple fight, good versus bad, the actual work of science, it can get blurry. The slow, careful job of looking at erosion, comparing climate data, building models that get reviewed by other scientists, it's not as exciting as a story about a cover-up. So that essential, grinding work with evidence, it often just gets drowned out. What's left for the public is the exciting idea, this possibility of rewriting history, but without seeing the fragile, complicated path that leads there. Or the real scientific criticisms that are still part of the conversation. That's the thing to see. It reminds you to listen to how the story is being told. To ask if you're being shown evidence or if you're being sold a narrative. The most careful people in this debate, on any side, they don't deal in absolute certainty. They deal in probabilities, in questions, in data that piles up slowly. They know that to rewrite a chapter of human history, that's an enormous thing. It needs evidence that's strong enough to hold up, not just from geology, but from archaeology, from climatology, from cultural history too. A good story isn't enough. It has to be a story where all the proof starts to point the same way, so next time you see a headline or a documentary about the Sphinx's secret age, just pause, listen past the music, past the dramatic questions, ask what evidence you're actually seeing, and ask what other explanations are being given a fair hearing. The real respect for that old statue, it isn't about accepting the most thrilling tale. It's about engaging with the actual mystery, the deep, patient mystery that's really there. A mystery written not in whispers of conspiracy, but in stone, just sitting there, silent, waiting for us to finally learn how to read it. The limestone layers at Giza tell a complicated story. There's water erosion on the Sphinx. That erosion suggests it's much older. It points to a time when the climate was wetter. Mainstream archaeology still places it in the Old Kingdom. But the stone shows rain that fell long before the pharaohs, so the timeline might be wrong, or maybe there's another explanation. It's still an open question. But the Sphinx does this. It creates wonder. It drives inquiry across different fields. It's a testament to ancient skill and to our own desire to understand the past. The lesson might be about humility, about questioning, about continuing to explore.